4 inches on the other side, and the hypotenuse, which is across from that box, is going to be what I'm looking for, okay? So I can label my sides. This is C, right? That's the unknown side I'm looking for. And remember, it doesn't matter what side you label, A or B. And now I've got A squared plus B squared equals C squared. And I am looking for C, not C squared. So I've got to take the square root of both sides. And again, I take the square root of this side, it just gives me C. So instead of writing the square root, I just went ahead and wrote C and took the square root. Okay. So A squared, let's do A is 4 inches. That's going to be squared. B is 3 inches. That's going to be squared. Okay, and then the square root of this whole thing is going to be C. So 4 inches squared equals 16. And then, so the number gets squared, then the units get squared. Number gets squared, units get squared. Okay, and that's all still going to be under the square root sign. So 16 plus 9 is 25. The units are still inches squared. Okay. Now I take the square root of the number, which is 5, and then the square root of the units, which gives me inches, just inches. So now I know that the magnitude of this side is going to be 5 inches. Okay, so my resultant vector is pointing that way, and the magnitude of my resultant vector is 5 inches. Okay, so that's how we do that. Now let's go ahead and do one of the problems from your packet. Okay, we'll quickly go over the first one, but we're going to spend most of our time on the second one. So the first one says that Steve rides in his boat 5 meters east. So something you might also want to do for those of you all who aren't very confident in knowing your cardinal directions, which is north, south, east, and west, just go ahead and make a little compass for yourself at the top of your page. Okay, north, south, east, and west. All right, so now you can draw your vectors in the right directions. So it says Steve's boat is going 5 meters per second east. Okay, so that's 5 meters per second east. And then it says 12 meters per second north. Okay, so I know that the 12 is going to be 12 meters per second north. Those are the only two vectors they give us. So that means I can just go ahead and combine these two tail to tail. So I know one is going that way and the other's going up. So I'm going to put the tail here and draw the rest of it going up. Okay, so 5 meters per second and 12 meters per second. All right, now I finished making my box. I draw my diagonal, and that's the direction that the resultant vector is going to go. And then I just go ahead and plug it into my equation. I got A squared plus B squared. Remember, I got to take the square root of it to get C instead of C squared, right? I take the square root of both sides, and that gets C by itself. Okay, and then I just plug in all my variables. 5 squared is going to be 25 meters squared per second squared, plus, remember, it doesn't matter which side I label A, which one I label B. Either way, this side is still C. So that's going to be 25 meters squared per second squared. If I go ahead and take this, or square B, that's going to be 144 meters squared per second squared. All of that under the square root symbol. All right, we're going to go ahead and add those up, which will be 169 meters squared per second squared. Square root of that equals C. And the square root of 169 is 13, I believe. Square root of 169. Yep, so that'll be 13 meters per second is going to be C. 13 meters per second. All right, so that's problem 1. We're going to go ahead and try to do, well, we're going to go ahead and do the next problem as well.